Right now, 400 million miles from where you're sitting, something is moving through the dark at 4.5 kilometers every second. It's covered in solar panels the size of a tennis court, the largest ever flown on a deep space mission. It's named after a song about diamonds in the sky and a fossil that rewrote human history. It's on a 12-year, 4 billion mile journey to a place no spacecraft has ever gone. And on the way there, on stops that were supposed to be nothing more than practice runs, it has already found things hiding inside small, unremarkable rocks that nobody predicted, nobody planned for, and nobody was even looking for. This is Lucy. And stop and sit with this for a second, because what Lucy just confirmed about two tiny asteroids you've probably never heard of is quietly rewriting the story of how every planet, including the one under your feet, actually came together. Before we go further, if you're new here, this channel breaks down real space missions, real discoveries, and the science behind the headlines without the fluff. If that's your kind of thing, hit subscribe, because what's coming later in this video hasn't even played out yet. It's still ahead of us. Now, back to Lucy. Lucy launched on October 16, 2021, from Cape Canaveral on a 12-year journey covering roughly 4 billion miles. Its destination, the Jupiter Trojans. These are two enormous swarms of asteroids that share Jupiter's orbit around the Sun, one swarm riding 60 degrees ahead of the planet, one trailing 60 degrees behind, both trapped there by gravity since the solar system was young. Nobody had ever sent a spacecraft to study them up close. Scientists call them fossils, not because they're made of bone, but because they're leftover, largely unaltered building material from the earliest days of the solar system, over 4.5 billion years ago. Study a fossil, and you learn about the creature it came from. Study a Trojan asteroid, and you learn about the raw material that built the planets, including Earth. The mission's name comes from two places at once. There's the Beatles song Lucy in the Sky with Diamonds, and there's Lucy the fossil, the 2 million-year-old skeleton of a human ancestor, discovered in Ethiopia in 1974 by paleoanthropologist Donaldjohanson, that transformed our understanding of where human beings come from. NASA's spacecraft was built to do for the solar system what that fossil did for us. Crack open the origin story, using pieces so old and so undisturbed that they still remember how everything began. The original plan was ambitious enough on its own. Visit not one, not two, but 8 different asteroids across 12 years, a record for any single spacecraft in history. Fly past worlds nobody has ever seen up close, including a rare binary pair called Patroclus and Menoetius. Test brand new instruments in deep space that had never been tried at this scale before, including a camera system called LORI, capable of resolving fine detail on objects hundreds of millions of miles away. That was the goal. That alone would have made Lucy one of the most significant missions NASA had ever flown. But none of that prepared anyone for what came next, because on the way to the real targets, Lucy made 2 pit stops. Small, unremarkable asteroids in the main belt between Mars and Jupiter, added to the itinerary mostly to test the spacecraft's tracking and imaging systems before the big encounters near Jupiter. Nobody expected headlines from a calibration stop. Nobody expected the first turning point of the entire mission to happen before the mission had even properly begun. They got headlines anyway. The first major turning point came on November 1st, 2023, when Lucy flew past a small main belt asteroid barely half a mile across, called Dinkinesh, the Amharic name for the Lucy fossil, meaning "you are marvelous." It wasn't a primary science target. It was a systems test, plain and simple. Point the cameras, check the tracking, make sure everything works before the real mission begins. The plan had originally called for Lucy to pass about 64,000 kilometers away, far too distant to notice fine detail. A late redirection brought the spacecraft within 431 kilometers instead, close enough to actually resolve the surface. Then the first images came down. Dinkinesh had a moon. Nobody had planned for this. Nobody had seen it coming in earlier ground-based telescope observations. A tiny satellite orbiting a tiny asteroid, discovered essentially by accident on a stop that was supposed to be routine. The team named the newfound moon Salam, after another fossil from the same species as the original Lucy skeleton. The two names bound together the same way the two objects themselves were now bound in orbit. Here's why that matters to you, even if you've never thought about asteroids for a single second in your life. Astronomers estimate that roughly 15% of small asteroids have companion moons, similar in principle to Dimorphos, a small asteroid NASA deliberately slammed a spacecraft into during the 2022 DART mission to test planetary defense. Every one of these companion moons is a clue to how small worlds form, collide, and hold themselves together, the same underlying physics that, on a much larger scale, decided how Earth itself ended up the way it is. A surprise moon on a practice flyby wasn't a footnote. It was a preview of exactly how strange this mission was about to get, because the story didn't stop there. As Lucy kept transmitting data in the minutes after closest approach, traveling nearly 1,000 miles farther from the asteroid system in just 6 minutes, the team noticed something strange in the additional images. Selam wasn't one object. It was two objects, smaller rocks physically touching each other, locked together in what astronomers call a contact binary. Picture two boulders gently resting against one another in zero gravity, spinning together as a single unit, never quite merging into one solid body. It was the first contact binary ever discovered orbiting an asteroid as its moon, anywhere, by anyone, in the entire history of asteroid science. Think about what that means. Not one surprise, not two ordinary rocks. Actually, a nested system, a moon made of two smaller moons, discovered by accident, on a mission that hadn't even reached its real destination yet. Lucy's deputy project scientist, John Spencer, later put the broader pattern simply. Contact binaries seem to be fairly common in the solar system. Common, and yet this was the first time one had ever been caught orbiting another asteroid like a satellite. University of Maryland astronomer Jessica Sunshine, who worked on the discovery, summed up what it meant for the field. There's a lot more complexity in these small bodies than we originally thought. And Hal Levison, the mission's principal investigator, reacted the way you'd expect a scientist to react after 12 years of planning ran headfirst into the unplanned. Dinkinesh really did live up to its name. This is marvelous. Space.com +2. If you're finding this as wild as I did when I first read the mission reports, hit like right now, because the next discovery is even stranger, and it happened on Easter Sunday, half a solar system away. Because on April 20th, 2025, Lucy reached its second target, an asteroid called Donaldjohanson, named for the very paleoanthropologist who discovered the original Lucy fossil back in 1974. This wasn't just a systems test anymore. This was a full dress rehearsal for the real mission, dense, deliberate data collection, designed to prove Lucy's instruments could deliver once it finally reached the Trojans. First discovered by astronomer Shelta Buss in 1981, Donaldjohanson had been observed from Earth for decades, but only from a distance. Only as a faint point of light with a strangely erratic brightness pattern that hinted something unusual was going on. Lucy flew within 600 miles of the surface at roughly 10,000 miles an hour, capturing images every 2 seconds as it went, and what came back reshaped how scientists understood this object entirely. Donaldjohanson turned out to be elongated, two lobes connected by a narrow, smooth neck like a barbell, or a slowly tumbling peanut roughly twice as long as New York's Central Park. It's another contact binary, formed when two smaller bodies gently merged after a past collision. But the real twist wasn't just its shape, it's its age and its motion. Scientists determined the asteroid formed around 150 million years ago when a much larger parent body, an asteroid called 163 Aragon, was violently shattered in a collision, and Donaldjohanson was one of the fragments left behind, a member of what's now called the Aragon asteroid family. And instead of simply rotating on a stable axis the way most asteroids do, Donaldjohanson is tumbling, chaotically, on a 251-hour day, a spin state so unusual that scientists had to model it as the product of a slow resonance effect that gradually dragged the object down from a much faster original spin over millions of years. Here's why that matters. This isn't just trivia about one distant rock. Donaldjohanson is a time capsule of a violent event from 150 million years ago, still recording the physics of that ancient collision in its shape, its surface craters, and its wobble today. Small craters across its larger lobe appear to have been erased, likely shaken loose by seismic vibrations following some later impact, a rock literally reshaped by shock waves traveling through solid stone. Every time scientists decode an asteroid like this, they're reconstructing a piece of the demolition derby history of the early solar system, the collisions and mergers that eventually built rocky planets, moons, and yes, the ground you're standing on right now. Now, none of this happened without struggle, and it's worth slowing down to actually picture what the people behind this mission went through. Consider what the team was working with. One shot. No do-overs, no second flyby, no chance to reposition the spacecraft and try again if the geometry was wrong. They wait, sometimes for hours, for a faint signal to cross hundreds of millions of miles back to Earth, confirming the spacecraft even survived the encounter intact. Then they wait again for the real images to trickle down, the ones that reveal whether years of planning just paid off or whether they missed it entirely. On the Donaldjohanson flyby, the team didn't immediately know, from the earliest data, that they were looking at a bilobed object at all. That understanding came later, stitched together patiently from imagery, light curve measurements, and rotational data, cross-checked against years of earlier ground-based telescope observations. Discovery, in real missions, doesn't arrive all at once in a dramatic flash. It arrives in fragments, over weeks and months, assembled by people staring at grainy pixels and stubborn numbers, refusing to stop until the picture finally makes sense. As one planetary scientist put it while reflecting on this run of asteroid encounters across the field, right now, we are in what has to be a golden age of asteroid exploration, and Lucy's team earned every bit of that description the hard way, one uncertain flyby at a time. And this is happening right now. As of this year, Lucy is deep in the main asteroid belt, cruising at speeds exceeding 30,000 miles per hour, heading toward the cooler, darker outer solar system. In November 2025, the mission released a massive trove of raw data from the Donaldjohanson encounter to the public, 23 separate data collections, covering every instrument on board, free for any scientist or honestly any curious person to dig through for themselves. And just this year, in 2026, two major scientific papers dropped almost back to back. One in the journal Science, laying out the final detailed picture of Donaldjohanson as a slowly tumbling bilobed peanut shaped by an ancient collision, and another in Nature Communications, arguing that the strange multi-body satellite systems Lucy has now found are not one-off flukes, but may point to entire hidden histories of collision, merger, and evolution playing out on asteroid moons across the solar system. Two accidental discoveries, one emerging pattern. And Lucy hasn't even reached its main destination yet, because here's the date that matters most, the one circled on mission calendars at NASA and the Southwest Research Institute. On August 12, 2027, Lucy will make its first flyby of a genuine Jupiter Trojan asteroid, Eurybates, a target it has been flying toward since the very day it launched. It will be the first time any spacecraft in history gets a close-up look at this ancient, unexplored population of objects. Not a test run, not a calibration stop. The real thing, the mission Lucy was actually built for, arriving after nearly 6 years of travel, 4 flybys already behind it, and a track record of surprising its own science team every single time it's gotten close enough to look. Zoom out for a second, because there's something almost unbearably poetic buried in all of this. A fossil named Lucy, dug out of the Ethiopian soil in 1974, rewrote the story of where human beings came from. 50 years later, a spacecraft carrying her name is doing the same thing for the solar system itself, chasing down fossils made of rock and ice instead of bone, scattered around Jupiter's orbit, untouched since before Earth had oceans, before it had a moon, maybe before it had even finished forming at all. We are, quite literally, the descendants of the same violent, chaotic collisions that built objects like Donaldjohanson. Every atom in your body was forged, scattered, and reassembled through billions of years of exactly this kind of cosmic demolition and reconstruction. Somewhere in that history is the answer to how a lifeless cloud of dust around a young star became a planet capable of producing you, sitting here, watching a video about a rock 400 million miles away. But here's what nobody can answer yet, not even the scientists who built this mission and spent over a decade waiting to reach it. If contact binaries and hidden multibody satellite systems really are as common as Dinkinesh, Salem, and Donaldjohanson now suggest, then how many more of these strange layered worlds are quietly orbiting undetected across the asteroid belt and beyond, objects that look, from Earth, like nothing more than a single, ordinary point of light? And what does it mean that 2 of the very first objects Lucy ever laid eyes on, chosen essentially as afterthoughts, turned out to hold secrets this significant? Was that luck? Or is the solar system simply far stranger, far more layered than we've ever had the tools to notice? Nobody knows. Not yet. Lucy is still out there right now, still falling through the dark toward Jupiter, still years away from the objects it was actually built to study, and if 2 practice flybys could rewrite the textbook, it's worth asking, seriously, what's waiting for it when the real mission finally begins? If this pulled you in the way it pulled me in, subscribe and hit that notification bell, because Lucy's Eurybates flyby on August 12, 2027 is going to be a moment worth watching live. Drop a comment and tell me which twist got you more, the hidden moon or the moon inside the moon. I read every one. Share this with someone who thinks space exploration slowed down after the moon landings, because it very clearly did not. And in the next video, we're going even further out to the icy, unexplored objects at the edge of the solar system that missions like this one are only just beginning to reach. I'll see you there.